Let's continue our talk about irregular shapes. So I have this shape right here. It looks kind of like a house. And I want to find the area and the perimeter. So I know some things. I know that the base here is 8 millimeters. It's not a real house because that's pretty small. The side length here is 6 millimeters. This slant of the roof is 5 millimeters. And the height of this triangle is 3 millimeters. So what would I do to find the perimeter? Who can tell me what the perimeter would be here? What would I add up? Yeah, this would not be the perimeter because this is inside the shape, right? So it would just be around the outside. So we have 8 millimeters plus how many sixes? So I could put 12 millimeters, right? Because there's another 6 over here. And then 5 and 5 would be another 10 millimeters. So what do you get all together when you add that up? 30 millimeters. How many people got 30 millimeters for that problem? That's the perimeter, yes. So P for perimeter. Now for the area, because I have some different kinds of shapes here, I have this shape in the roof is a triangle. Actually, I could say I have 2 triangles, or I could just, what would be the base of this triangle right here? What's the length of the whole base? 8 millimeters. So who can tell me how do I find the area of the triangle? Base, so yeah, just that big triangle. The base of 8, the height of 3. 1/2 times base, yep, the base here is 8 millimeters times 3 millimeters. Because remember that the triangle is half of a rectangle, right? I don't have this and I don't have this, so I need to get rid of those areas. That's why I take half. So you could do this 8 millimeters times 3 millimeters and then basically divide by 2, right? So 8 times 3 is 24. What's half of 24? 12. So we have 12 millimeters squared. Am I done? Is that the area of the whole house? No. We want to find, that was just the area of this triangle up top. Now we want to find the area of the rectangle. Can anyone tell me what the area of this rectangle would be? 6 times 8. 6 millimeters times 8 millimeters, which is 48 millimeters squared. So the area, if I add the rectangle and the triangle together, the area of the triangle plus the area of the rectangle, I'm going to get 60 millimeters squared, because my area is always in square units. Any questions on that one? Did you all get that? Yes? Yes, because that's the area of the triangle plus the area of the rectangle. Okay, let's move on then to circles. So let's talk about circles. I had a student once tell me a little ditty that they use to remember the formula for circles. They say cherry pies delicious. Cherry pies delicious. Apple pies are too. Sorry, that should be a lowercase r. I just got messed up because I was writing the 2 too soon. Apple pies are too. Okay? So it's just a way to remember these formulas. When we have a circle, okay, which is not a polygon because none of the sides are straight, we have some special rules. Circumference goes around. This is the formula right here. The C is for circumference. So circumference starts At one point, circumference goes around the outside of the circle. So, and then where does this D come from? Well, diameter goes all the way across through the center, and the radius starts in the middle and can go anywhere on the circle. So here is R equals radius, which is half the distance. So what's the relationship between the diameter and the radius? Well, if I have a circle and I know that the radius is 5 meters, who can tell me what the diameter of that circle would be? 10 meters. Okay? If I have a circle and it has a diameter of 20 centimeters, who can tell me what the radius would be? Anyone? Half of that, right? 10 centimeters would be the radius. So we need to be able to go back and forth between finding the radius and the diameter, because we use the diameter to find the circumference and we use the radius to find the area. Okay, so let's talk about the circumference for a minute. So circumference equals pi times diameter. Well, what do you know already about this number pi? Pi is pi, which is approximately, a lot of times we use the approximation 3.14, but this number is actually what we call irrational, because the decimal goes on and on and on and on for infinity. Do you know what day people celebrate Pi Day? Yes, March, because that's the 3rd month, 14th, because that's the 14th day, well, 3/14. And then in 2015, we had an epic Pi Day, because 3.1415926, I don't know. I think 3 or 4. But if you have a calculator and you press pi, let's look for the pi button. Here's the pi button. I have to turn it on. First, turn it on. Press pi. If we press enter, you can see, there you go. Okay, you can see that this number, these are only the first few digits of pi. This is not the whole thing. So it does make a difference. If you're in construction and you're trying to construct an actual circle, you would want to use the real pi, but a lot of times, because we don't always have a scientific calculator, not every calculator has a pi button on it, we could use 3.14 just to get an approximation. That's the reason why I use this wavy equal sign. The wavy equal sign means approximate. Okay, so we're rounding it off, and the reason why we use ... is it keeps going on for infinity. In fact, I actually think this last 4 might really be a 3 and that it's rounded. I'm not sure about that. 100%. Okay, so that's a little bit about circles, but let's talk about how we can figure out the circumference. So if I have a circle and I know the diameter is 10 centimeters, what that basically means is, since our circumference is pi times 10 centimeters, well, how much is that? It's approximately 3.14 times 10, right? So we would take our pi, with the glare and everything, take our pi, ooh, that's better over there, times 10, and we would get 31 point, let's round it to the nearest 10th place. So that's rounded to 10th, rounded to 10th place, right? 10th, does everybody get why that's a 10th? And what's my units? Centimeters. So that really basically means that this diameter here fits around the circle a little over 3 times. This would be 1 diameter, another diameter, another diameter, and 0.14 diameters, right? 1 diameter, 1 diameter, 1 diameter, because it's fitting around a little over 3 times. And the circumference goes around the outside of the circle. Well, what if I wanted to find the area? Who can remember what the formula for the area is? Yeah, and I remember apple pies are 2. Pi r squared. So if I have a circle that has a diameter of 20 centimeters, I need to find out something first before I can find the area. What is the missing bit of information? This is the diameter here. What do I have to find before I can use this formula for area? Ah, half. Half the diameter. Half the diameter is the radius. The radius is equal to 10 centimeters. That's the reason why I'm using 10, because it's a really friendly number to work with, okay? So the area equals pi times, tell me what to plug in for the radius. 10 centimeters squared. And the reason why this is because a radius squared is literally this, here's a radius square. How many of the radius squareds, that's a radius squared, that's a radius squared, that's a radius squared. How many of them fit inside the circle? But then this extra we have to shave off, right? We don't want the whole square. So little less than 4, correct? Well, actually 3.14 radius squareds, right? A little over 3 radius squareds. That's where we get the idea of pi from. So now this is going to be, let's use 3.14 just as an approximation, times, what's 10 centimeters squared? 10 times 10 is 100 centimeters squared. And if you multiply by 100, what do you do to the decimal? Move it over. 1, 2. 314 centimeters squared would be the area. Okay? The area of this circle. So the reason why I'm bringing all of this up is because when we have irregular shapes, we have to be able to put these formulas to use. Like for instance, they actually do have a problem very similar to this. Let's say now I'm going to go and I want to deal with my windows. Okay, let's imagine, has anyone ever seen a window that looks like this, like a bay window, or I don't know, circular window? So this is where it gets a little bit tricky. Let's say this is 10 meters and this is 10 meters. Actually, let's make it something different just so it's not confusing. 8 meters. And then look at that. I have a circle. So if I want to find the perimeter, I want half of this circumference, right? I only have half a circle here. So what could I do? Do I have enough information to find the distance all the way around? What's the distance around that's the easy part, the rectangle? The distance around just here, here, and here, because I want to find this distance separately. Yes. So far I have 8 over here, 8 meters, 8 meters. We're going to find the perimeter. 8 meters plus 10 meters plus 8 meters. So altogether that's what? 26. 26 meters. But how do I find this distance here? It's half of the circumference, right? How would I find the circumference of this circle? This is going to be half of circumference, right? So yes, so the circumference is pi times the diameter, and because we only want half of the circle, I'm going to divide it by 2, because we have half of a circle. So does anybody, can you tell based on the drawing what the diameter is? How do you get 10? Yeah, the diameter is 10 meters, right? So if I plug that in, C equals 3.14 times 10 divided by 2. So we can use our calculator for that. You can use the actual pi button if you want. So there's pi or 3.14, but you're going to get different answers if you use pi times 10 divided by 2. And we're going to round this off. Let's round it to the nearest tenth. 15.7 meters. So that's the circumference of half the circle because we divided by 2. That's why we divided by 2, because we're taking the circumference of half the circle. So now we have 26 plus the 15.7 meters gives us a total distance around the outside of what? I don't know. Let's add it together. 26. 41.7 meters. That would be our perimeter all the way around the outside of the bay window. Now, if I wanted to know about the area, to find the area, I need the area of the rectangle, plus area of half of the circle, right? To find the total area. So what would be the area of just the rectangular piece right now? Just the shaded area that I have there. 80 meters squared. How do I find the area of this circle right here? I need to find the radius. What's the radius? If the diameter is 10, what's the radius going to be? The radius equals 5 meters. Now, for the area of half of the circle, let's just write that out. Half of circle, we have pi times 5 squared. Does everybody know where I got those numbers? Pi times 5 squared. Why is it 5 squared? Yeah, half of the diameter is the radius. So I have 3.14 times, what's 5 squared? 25, right? 3.14 times 25 equals 78.5. Well, because I didn't use pi, so I didn't round it. So we're going to add those two things together. Area of half the circle plus the area of the rectangle. Together that adds 80 meters squared. Here's our meters squared plus 78.5 meters squared. And what do we get when we add those two things together? $158.5 meters squared. So this is the area of the whole shape. Any questions on that? Okay, now take your paper and you can go ahead and try it.